Okay, everyone. So like I said, our next speakers are from CARIAD, and it's our first duo in this track today. So we're going to have two of them. We're bringing Sebastian and Lukas to tell us about code to road in under 12 hours. So Sebastian is the product manager, and Lukas is the domain architect, and they're part of a team at CARIAD, which is the software construction, test, and cloud. I hope I didn't mess this up. So give it up for Lukas and Sebastian.
So also from us, warm welcome here at the We Are Developers. So you do not need to do push-ups, but we want to do some git commit and check-ins because we want to do and tell you about Code to Road and our journey in the Automated Driving Alliance. So first, we want to tell you who we are and what we do. And yeah, as already said, my name is Sebastian Roßner. I'm the domain product owner of the software construction, test, and cloud domain that we have in the Automated Driving Alliance, or short Socotech, and I brought with me my architect, Lukas.
Exactly, so thank you. Really happy to be here. My name is Lukas. I'm the domain technical architect, so more on the technical implementation side. Yeah, excited to be here.
Yes, and CARIAD was the right pronunciation, so Lukas would start with some words about CARIAD and what we do.
Yeah, so a lot of people know VW, Audi, Porsche, and so on. Not so many people know CARIAD. I hope that changes soon. We're a company founded 3 years ago, and we are the powerhouse of the software powerhouse of the Volkswagen Group. So some people may also have heard the talk of Peter, our CEO, this morning. I don't want to go too deep into that. But at CARIAD, it's important we have 4 pillars, 4 strategic goals. We have the digital experience, our infotainment system. You can experience that in the Audi Q6 e-tron and our booth in Hall 2. We want to also provide all of the infrastructure and all of the operations, maintenance, software lifecycle stuff, over-the-air updates. And we want to, or we are building up a scalable tech platform, so all of this ECU control, all of the different computers we are building into those cars and making it scalable to have it ready for entry, but also mass market, and also premium cars. And why we're here today, we also have one strategic goal. It's the automated driving. And for us, we have partnerships, and one of those partnerships is together with Bosch, the Automated Driving Alliance. And Sebastian is going to tell a bit more about it.
Thank you, Lukas. Yeah. So we talked a lot of the Automated Driving Alliance, and Peter today in the morning already mentioned it. So that is our answer, or our European answer to building a complete software stack for the autonomous driving. So what is the Automated Driving Alliance? It's a cooperation. It's a development cooperation. It's not a joint venture between CARIAD and Bosch. We want to develop a complete stack for the autonomous driving from the middleware up to the function level. And it's amazing. It's over 1,500 software developers on daily basis committing code that we see later. And as we already have derived from our vision from CARIAD, we want to have automated driving for everyone. So that's important. So there is a scale. We need to have a scaling. We want to be in the VW. We want to be in the Porsche. So that is important. And as I said, the full stack driving is important. And what does it mean? What is the full stack driving? So and what are the two companies in the cooperation? So of course, Bosch is a strong partner in our Swarm services, in the platform development, in the middleware. That is where they accelerate us. We have together defined quite amazing process methods and tools. And we, as the VW Group, we bring the scalability, we bring the fleet management, we bring the system engineering, and we provide the product readiness. We deliver to our end customers. And as said, the scope is safety and parking is out of scope, but the complete end-to-end data cycle, what we will focus on, is the foundation that we want to talk today, and the product we are building on this foundation is a level 2+ driving function, a level 3 driving function, and a level 4 driving function visibility study. But yeah, we are here at the We Are Developer. we know we are from the automotive industry. I'm not sure if everybody knows what the L2, L3 plus means. So that's the reason Lukas will give an overview after we see we are on the road, of course, because we are driving there. And what does it mean where we are driving, specifically the different levels is now Lukas telling us in a short 101 for automated driving.
Yeah. So just for me to get a feeling, how many are involved in ADAS development, something driving assistance features? Okay. So next steps are probably not so interesting for you, but for the other guys. So we have in general 5 levels. That's rather common knowledge, so nothing special here to know. But level 1 is established like since decades already. It's the usual cruise control. So as long as you only have like one element, like the speed control or the steering or whatever, it's a basic driving assistance, and it's only one-dimensional. So either steering or acceleration, deceleration, and so on. What's a really, really, really broad field is the level 2, because in the level 2, it mainly says, okay, it's assistance, active assistance in 2 dimensions, maybe, and still the driver is responsible. So even if we are driving a BMW or something like, all of the well-established systems, they already can do lane changes, they already can steer, and you basically do not have to do anything, but you are responsible for. And that's the main difference between level 2 and level 3. In level 3, we have the responsibility within the car, and if there is a scenario where the car says, okay, in this environment I'm not feeling confident to drive, the driver needs to take over. So that's the difference between level 2 and 3. So it's not so much in the function side, but more in the safety and in the controlling part. And so basically we start with level 2 plus whatever features. And as we said, our passion is to bring automated driving to everyone, which means not only to the premium cars, which can cost a lot of money, and we couldn't put all of the sensors in there which we want, but also in the entry cars. And a lot of functionality in level 2 can be done with only a front camera or only like a very reduced sensor set. This can already reach out for a high level of functionality. We most certainly need the full sensor set if we take the responsibility to the car. That's the main point. But we want to have a scalable platform, so we want to have one platform which can apply to all of those solutions. But what's in this platform? So what do we need for driving assistance systems? We have, on the one hand side, the sensors and the sensor inputs. So we have the cameras, we have the radars, we have LiDAR sensors, we have ultrasonic, whatever. And all of the sensors need a perception system, so you actually take data out of the sensors. You have the camera drivers, you have the line detection, and so on and so forth. And with video perception, this is like one of our main pillars in the Automated Driving Alliance. We do that on our own. And it's highly relying on deep learning networks. So we need a lot of data, and we need a lot of deep learning methods in the cloud to train those algorithms and put them into the car so we can detect all of the objects and so on video, but also on radar. And then the fusion basically takes the perception input from the camera video perception, from the radar perception, and so on and so forth. And the output of the fusion is that we have one environmental model. So we call it environmental model because it basically puts you in a position where you know which objects are around you, where are the lanes, where do I have some obstacles like from the walking way, where are pedestrians, where are cyclists, how fast do the objects move or are they still standing. All of the stuff is coming together in the fusion, and we have then one common view about everything. There are no dead angles, angulus mortis, tote winkel, or something like that if you have a full sensor set and so on. Also, in the fusion, we have as an input the map. The map is also a very essential thing. We are learning an own behavior map, which means that with the swarm, with the cars already driving around, we are observing like other cars, how do they behave, in which corners, which speed do other cars have usually in this place. And if we have the map data, we can foresee around the corner, and we know, okay, around the corner, it's official speed limit 100, but everybody drives only 90, and that makes a much more smooth ride. And so this is also a very important part. We are training our own maps based on basic maps, but all of the behavior stuff, we are training that on our data, which brings us as a Volkswagen group in a huge position because we have so many cars, and it's data not everybody has accessible. And this part is especially the part which is usually not so much done in the European market, but usually bought in from other people. What's usually done in the European market is the driving function itself. So I assume I have a sensor, I assume I have some inputs, and I know where the objects are, then I can do a driving logic. And also this is done in the automated driving alliance. So we have the full driving stack from the sensors to the logic, okay, when do I accelerate, brake, and so on. What we're not doing inside the alliance is the actual actuator logic. So we always base on an existing car. You just seen the ID bus. We're integrating into those series cars and using the interfaces of the dependent platforms to integrate in there. Yeah, so much for that. And then I hand over to you on how do we do it.
Exactly. So first of all, if you have a development cooperation, so you somehow need to have a playground, I would say. And it is hard, either you jump onto the playground on Bosch or you jump on the playground on CARIDIANS side. So both things are feeling different for one of the parties. And that was the main reason we decided, okay, we need to build a neutral playground, and that was also a good decision because we could create the playground where our developers are working ourselves, and the main motivation is that we want to own our tools. And for that, in that development cooperation, we took an hyperscaler. It was Microsoft in that case. And as you know, yeah, there is no cloud. There is just somebody else's PC. But still, the basic mindset is the working or the playground is in the cloud. And we have a strong DevOps mindset here. So all our tools that we develop, we maintain and operate by ourselves. And we build, test, and code and monitor them in parallel to our embedded source code development. And the big benefit of this is really, if you control your tools, you can further develop your tools in parallel to your project progress. And what are the topics that we implemented on this cloud platform are our 3 loops. So we have 3 major development loops. It's the DevOps loops that I just already mentioned shortly. We have the deep learning loop and the data loop. And let's dive deep into these 3 loops to really showcase what we have there. So as you see here, these are the 3 loops, and the fuel in the automated driving alliance of the development is the data. And that's the center of all 3 loops. So either, if you look at the big data loop, this is the loop where we collect the data. So we have, as Peter has already mentioned, the ID fleet already on the road collecting swarm data. We have additional data collection fleets who are driving around in complete Europe to collect data that we need, that are trigger-based, bringing on in the data. So this is the input topic. Then the second big loop that Lukas was already mentioned for the AI training, for the video perception, is taking the data, labeling it, doing quality assessments, training models, and doing AI models out of this that are then feed into our development loop. And that's where I want now to focus on. In the development loop, and here also, even when we have a code-centric part in our development, still the data is essential also for the embedded development loop. So we take the data, we use the data to do a data replay on the systems, and we provide this to our developers on the desktop as well in the cloud. Afterwards, of course, the software developer is programming the algorithm, updating, bug fixing, whatever. We have a fast CI/CD pipeline that we will cover in the next slides. And then also, based on this, the developer can request certain topics to be collected again. So with our development fleet and with the new software that was developed, data collectors are running in, providing new data, and the cycle repeats with new data. And now we really want to do a deep dive into the embedded development, and I'm happy that Lukas will take over that part.
Yeah, we want to talk about CI/CD, but I mean, before we talk about CI/CD, we need to understand, like, okay, how do we build the software at all, right? And how do we test the software at all? When we started the corporation 2 years ago, our integration or like our build structure looked a bit like this. So we had on the top, at the root, we had an integration repo. Then, of course, we did packages with the whole system. And beneath, we had, for software compositions or software components, own repos. And we've built them separately. And of course, they existed out of libraries. And so we had another layer on software which we needed to build. And we had some external dependencies and so on and so forth. So one bigger function to develop had around about 200 repositories, which was necessary because if you would have put them back to the time into one repo, huge build times, whatever. And we wanted to tackle that down, make it granular, and only build the stuff which changes. But with this huge dependency tree, we had some struggles because we needed a very, very complex CI system which actually detects, okay, which parts of the whole system now has changed, and okay, there's a version update, and then we needed to patch every dependency in the dependency tree to build a new system version, and then we built complex pipelines which are making integration builds once a day or something like that to have a daily report if some changes in package A are conflicting in integration, and so on and so forth. So the actual result of like having such things was that for each bigger function, we had around about 5 hours of build and integration time, and round about 1 integration per day. And if it fails, we needed to fix, and then again and again. In the Alliance, we decided to start things a bit differently. We said, okay, we are not a software supplier, right? We are one project. We are all developing together in this. We don't have some components from this entity and from this, but we all do it together in one repo. This gives us the chance to have a very, very slick integration system because you only need to build once, and then you have the whole system. We did that using CMake and as a build system because it was the common build system of each and every developer. And was easy to start with. We had then some caching mechanisms for CMake. And in the very end, when we put everything together, we had this one repo for the embedded code, including all of the dependencies from the neural networks and so on. And we had round about 45 minutes build and integration time and round about 80 integrations per day. So every time you have a feature request and it's going to be successfully merged into the main branch, then you have one integration. We did that round about 80 times per day with round about 1,000 developers. We were already pretty proud to reach this and to have this really scalable big system. But still, 45-minute build time for every change is a bit much. So we decided to switch from having a CMake component, we switched to Bazel actually. And we had way better caching mechanisms, and we reduced the usual build time from 45 minutes to 10 minutes. So imagine that you have really like 1,500 developers actually pushing code every day into this repo, like 1,000 pull requests open, I don't know, and we actually reduced the build time to 10 minutes. That's crazy if you don't have huge changes. Of course, if you change all of the code and like you have to rebuild everything, it takes longer. But this was a big enabler also for the client side. So the developer clients needed much less computing capacity, and there the effect was even bigger from the previous time. But we also only improved to 100 integrations a day. So even if we reduced the build time by the factor 4, it's only like 20% roundabout shift in the integration there. This is mainly because of testing, because the testing effort is still as high as before, and we are testing a lot of things, not only in the cloud, but also locally, also on the target. So here again, we have 1,000, 1,500 developers. It depends on who's in vacation or not. Then we have the software build. We do like 5,000 build runs each week. And then each of these PR builds is then building the whole functionality, and then a very, very huge scale of tests in the cloud. Also already doing resimulation and testing. And then we also have our target ECUs in the data center where we can use them and utilize tests directly on the target. And this is currently very much growing, which helps us a lot because this is currently the bottleneck we're facing. And this actually is really, really important because we're so close to the sensors with our software that actually there are a lot of things we detect only on the target hardware, not on x86 with other data inputs, which we can only inject to a later point in time. Yeah, roundabout, I said, roundabout 100 pull requests a day, roundabout 500 a week. But no, we're not driving 500 software iterations in the cars on the streets. We only have like roundabout 25 per week right now. We're building up more and more cars to have more and more capacity to also test inside the cars. And the key here in the testing on the cars is to reduce the change failure rate. Because cars, you cannot scale cars in to I don't know, 3-4 digit number. You have a limited place of cards. As soon as we resolve the bottleneck with the ECUs, we're testing on processor level, on SoC level. The cards are the bottleneck for actual tests. And everything we do, we need to focus on getting the change failure rate down to test so many things in higher scaling test levels to only have really some edge cases which we detect in the car. But nevertheless, we will drive around a lot, and we do drive around a lot. And one of the nice things in our project, which I really, really like, every Friday there's a Friday drive, and we drive around on our test route, and it's streamed to all of the developers, and we can watch how the people drive through the route, and you see the new bugs, and then you tackle them. So that's really a really nice method to also share transparency on how is your software, which you just push to the main. On Friday you can see it by other people driving the car. Yeah, but to testing, I want to hand over to you. I think you have some more insights than I just gave.
Thank you, Lukas, for telling us how we achieved from code to road in under 12 hours. And it's important, as we saw, it's not to be fast, but it need to be secure, and it need to be with a low change failure rate. And the change failure rate is enabled by embedded testing. So what do we test and how do we test? This will be now the next focus. And we more or less divided the testing into 3 major elements to use the capabilities of the cloud and of target hardware. So let us start. Our strategy for the validation is to have it done within 2 weeks, and that's totally changing the way we're working. If you imagine what Peter said in the morning, in the past it was 50 months for bringing a car out. We want to do a software update every month, so reducing from 50 to 1 month and deliver it out to the customer, and that's for that. And you need to do everything. Same as you provide the car after 15 months, you need to do the same documentation, you need to get the same approvals, and so you need to test from software to hardware. And the way why we need also a hyperscaler is you need to scale in the cloud. So you need to take the software, you need to do it on normal x86 hardware, and you need to do a lot of scenarios. And scale in the cloud is majorly the software in the loop testing. So we are running already around 15,000 scenarios a day, and more and more are coming there. The second topic is if you're just running on x86, you're not getting the time constraints. You're not getting the hardware accelerators on the system on a chip. And that's the second topic. So You take the software, you bring it on the system on a chip, and then we call it processor open loop or processor in the loop testing. So we take the SoC, we have a data center, we have a center near a major internet hub where we can stream in the data, and there we have already our SoCs near to our data center where we can stream the data on the SoC and do embedded testing on the chip. That enables us to do already time constraints and to test on the hardware accelerators. But still, there is the problem that you do not have the full package. So in the end, you need to validate on the target hardware. And the target hardware is the most crucial for the validation. So what we are also doing, we're building up hardware open loop proving elements that are also in the cloud where we pipe in the data that we collected. So every time there was a bug in the car, we take the sample, bring it into the cloud, and we make regression tests on the target hardware, piping in the data again in an open loop system to validate against these topics. And the final and biggest integration step is then the hardware in the loop proving ground, where you also have then the integration with other components in the vehicle, because we have a central control unit for the ADAS-AD. You also need to have connections, as we already said, to the steering and to really provide the trajectory to the actoric. That is the final step then for validation. And to repeat all of this, so what we see here now is the difference between the hardware open loop, processor open loop, and software open loop. So if you just take the car, and we saw the ID bus where we are driving on the road, that is the final approval stand, more or less. We're driving around, there is a bug, we collect the data. And then if you remove the sensors of the vehicle, but you still keep the central control unit, and you pipe in over the same interfaces as if you connect the camera. That is the hardware open loop. If you then also remove the input data and you just use the system on a chip, that is then the processor open loop, and for scaling, that's the software open loop proving ground that we have there. All of this is running in parallel and is pushing us to do a high quality in testing, and that is also the reason why we have a low failure rate then in the vehicle, and 4 out of 5 new software releases that our developers are getting on the main branch are drivable in the vehicle. So what we now also brought with us is a small video that you see this in action, how we work. So it's take 1.5 minutes, just enjoy, see us there in the video, what we are doing in the Automated Driving Alliance, CARIDIANS and Bosch together.
Automated driving. A collective passion of those daring to reach for the technological marvels that lie ahead. Continuously developing and delivering safe software, bringing the convenience and comfort to all vehicle classes. Automated driving for everyone. This spirit and aspiration is embodied by a joint development force, Bosch and CARIAD. Future-minded professionals and engineering experts from both sides form the Automated Driving Alliance. Fueled by the desire to develop software that will hold up to the highest safety and security standards, following a data-driven development approach. The Alliance's solutions offer the highest degree of modularity, scaling across brands and vehicle classes. We work with meticulous attention to detail during integration and roll up our sleeves when it's time to test. We provide safe and convenient automated driving functions for drivers, for pedestrians, for cyclists, for you.
Thank you. Last but not least, of course, we are here at the WeAreDevelopers. We have a booth, and we're happy to answer your questions. And if your question is not answered here on the stage, we're happy to find you at the booth and answer your questions there. But I think, let's see which questions are there, and let's try to.
Do we have time for questions?
Let's double check, because I think we have 1 minute.
Yeah, as said. So,
Okay.
if any questions are left, unanswered.
It depends on how fast you can. Let's go with one, and then the other ones will leave it up to you afterwards.
Amazing.
So, and this should be a quick one. Is there an intention to open source results from this development cooperation?
So currently we are participating in some open source projects, but we did not publish a major part. So what we normally do, we are not reinventing the wheel, but we are using open source software. And if we make an enhancement or if we fix the bugs, we also push this back to the community.
Yeah, but I really want to emphasize, so like for our simulation tooling, it's very important for us to build up on open standards. And it's also our goal to contribute to those standards. And Bosch is doing that already quite a while. And we are also, as Alliance, it's a bit tricky, want to contribute to that.
Okay, yeah, unfortunately we won't have time for more questions. Now we're going to have a 10-minute break and then we'll be back. But before we leave, I would like you to give it up for Sebastian and Lukas.
Thank you.
Thanks.